Right now, more than 34,000 trackable objects, satellites, debris, and more whiz around Earth at 17,500 miles per hour. Military satellites, spy networks, communication arrays tracking everything from GPS to global communications. But the peaceful facade of space ended long ago. In 2007, China used a kinetic kill vehicle to destroy one of its own weather satellites. And by 2021, India and Russia had each demonstrated anti-satellite capabilities, showing that space warfare is no longer theoretical. The age of space warfare isn't coming anymore. It's already here, and the next 5 years will determine whether humanity's greatest frontier becomes our newest battlefield. What happened next changed everything about how nations view conflict beyond Earth's atmosphere. The 2024 turning point that changed everything. The real turning point came when ASAT tests by multiple nations, including China's 2007 kinetic kill vehicle, the US's 2008 SM-3 test, India's 2019 incident, and Russia's 2021 test, proved that satellites can be destroyed in orbit, sparking a rapid arms race. These demonstrations shattered previous assumptions about space as a sanctuary and revealed that orbital warfare capabilities had moved from theoretical concepts to operational reality. The technical achievement represented an exponential leap beyond anything humanity had witnessed in space-based warfare capabilities. Previous anti-satellite weapons required individual targeting sequences, often taking hours or days to position for a single engagement. China's 2007 kinetic kill vehicle that destroyed their own weather satellite took months of preparation and could only engage one target. Russia's co-orbital interceptor satellites from the 2010s required weeks to maneuver into position for each potential engagement. These ASAT events shattered previous limits and demonstrated multi-target engagement potential, triggering new space defense initiatives worldwide. Within days of these tests, major programs accelerated development of space defense platforms. China fast-tracked its counterspace systems, the U.S. Space Force expanded its ASAT research, and NATO declared space a new operational domain in 2019. The Pentagon immediately activated Space Force's Operation Sentinel protocols, reassigning classified reconnaissance missions to monitor potential threat satellites. Russia's Roscosmos announced an accelerated timeline for their Cosmos defense platform, originally scheduled for 2027 deployment, but suddenly moved to late 2025. China responded by revealing their Tiangong military space station had been operational longer than previously disclosed, equipped with what they described as defensive countermeasures against hostile space platforms. The European Space Agency held emergency consultations with member nations about establishing an independent military space command within 6 months, rather than the previously planned 3-year timeline. India's Defense Research and Development Organization received emergency funding approval for Project Kali, their directed energy space weapon program that had been in development limbo since 2019. Even smaller spacefaring nations began rapid militarization efforts, with South Korea announcing their first dedicated military satellite launch within 18 months and Australia revealing classified agreements with the United States for joint space defense initiatives. This acceleration represented a complete transformation of space militarization timelines that had been measured in decades. Before these demonstrations, military analysts projected gradual space weaponization over a 20 to 30-year period as nations slowly adapted existing technologies for military applications. The successful ASAT tests compressed these projections into a 3 to 5-year arms race, as every major power recognized that space warfare capabilities had suddenly become operational rather than theoretical. The demonstrations fundamentally altered how military strategists viewed civilian space infrastructure. Previously, Commercial satellites operated under an assumption of sanctuary, protected by international agreements and the practical difficulty of targeting individual assets. The ASAT tests proved that civilian satellites could be disabled as collateral damage in any space conflict, making every GPS constellation, weather monitoring system, and communication network a potential casualty of space warfare. Military space budgets surged 9.4% in 2024, its steepest rise since the end of the Cold War, reflecting both ASAT developments and increased space security concerns. Commercial satellite operators began demanding military escort protocols for high-value launches and started designing redundant systems specifically to survive coordinated attacks. The vulnerability of space assets had transformed from low-risk investments to active military targets requiring comprehensive protection strategies. The ASAT capabilities demonstrated that space warfare had evolved from the realm of science fiction speculation into operational military reality. Defense contractors worldwide received emergency funding to accelerate space-based weapons programs that had been progressing slowly through normal procurement cycles. Lockheed Martin's Aegis space platform moved from conceptual design to prototype construction within 6 months. Boeing's orbital missile defense system received full funding approval after years of budget delays. Northrop Grumman's space-based laser project transitioned from research phase to active development. Intelligence agencies revealed that the successful ASAT tests represented just one component of comprehensive space warfare capabilities that had been developing in secret for years. Reconnaissance satellites had observed construction of similar platforms in various stages of completion, suggesting that multiple nations possessed or were rapidly acquiring comparable anti-satellite engagement capabilities. By late 2024, classified intelligence assessments indicated that at least 6 nations had developed or were testing similar targeting systems. Russia's Cosmos platform conducted what they described as navigation exercises, but demonstrated precision maneuvering capabilities consistent with weapons deployment. China's Tiangong station performed unexplained power surge tests that matched electromagnetic pulse generation profiles. The United States conducted classified launches under Space Force Operation Security protocols, with payloads and missions remaining completely undisclosed. These developments created an unprecedented compression of military space program timelines. Projects that had been scheduled for deployment in the 2030s suddenly received emergency funding and accelerated development schedules targeting 2025 and 2026 operational dates. The traditional decade-long weapons system development cycles collapsed into 18-month crash programs as nations raced to achieve space warfare parity. The immediate aftermath established new operational realities for space-based assets. Military satellites began implementing evasive maneuvering protocols, constantly adjusting orbits to avoid predictable positioning. Commercial satellite operators started launching backup systems and implementing automated threat response systems. Ground-based space tracking networks expanded their monitoring capabilities to provide early warning of hostile satellite movements. International space monitoring organizations documented a 280% increase in satellite maneuvering activities, indicating that the entire orbital environment had shifted from stable, predictable operations to active threat assessment and defensive positioning. Space had transformed from a peaceful frontier into an active military domain, where every asset operated under potential threat conditions. The ASAT demonstrations established the new baseline reality that space warfare capabilities were no longer theoretical future possibilities, but present operational systems capable of immediate deployment. Nations could no longer plan space militarization over comfortable decades-long timelines, because the technology had already matured beyond experimental stages into deployable weapons systems. The compressed timeline meant that space warfare preparedness became an immediate national security priority rather than a long-term strategic consideration, fundamentally altering how governments approach space policy and military spending priorities. But governments weren't the only players adapting to this new reality. Something unexpected was happening in the private sector that would reshape the entire landscape of space warfare. The new players reshaping space combat. SpaceX now operates over 5,400 Starlink satellites in low Earth orbit, giving Elon Musk's company more space-based assets than the combined military satellite fleets of Russia, China, and India. Blue Origin controls manufacturing capabilities for rocket engines that power both NASA missions and classified Defense Department payloads. Virgin Galactic maintains suborbital flight systems originally designed for space tourism, but easily adaptable for rapid satellite deployment or space-based reconnaissance missions. These private companies didn't set out to become military contractors, but their dual-use technologies have made them inadvertent participants in the emerging space warfare landscape. The transformation happened through what defense analysts call mission creep. SpaceX developed reusable rocket technology to reduce launch costs for commercial satellite deployment, but those same Falcon 9 rockets now carry classified Space Force payloads on a monthly basis. Blue Origin's New Shepard system was designed for civilian space tourism, yet its rapid ascent and precision landing capabilities make it ideal for deploying small military satellites or conducting space-based surveillance missions. Virgin Galactic's White Knight II aircraft and Spaceship Two combination can reach the edge of space within hours of launch authorization, providing capabilities that traditional military systems require days or weeks to achieve. Traditional nation-states no longer monopolize space military capabilities. The United Arab Emirates operates the Mohammed bin Rashid Space Center, which has launched reconnaissance satellites with resolution capabilities matching those of established space powers. South Korea's Korea Aerospace Research Institute has developed indigenous satellite technology and precision launch systems that could easily support military applications. Brazil's National Institute for Space Research controls satellites with Earth observation capabilities sophisticated enough to track military movements across multiple continents simultaneously. These emerging space powers built their capabilities by partnering with private companies rather than developing traditional government-controlled space programs. The UAE contracted with private manufacturers to develop their satellite technology, allowing them to achieve advanced space capabilities within 5 years rather than the decades required for traditional military space programs. South Korea leveraged partnerships with commercial launch providers to establish satellite constellations that would have cost their government billions of dollars to develop independently. Brazil's space program expanded rapidly through commercial agreements that provided access to cutting-edge technology without the research and development costs that historically limited space access to superpowers. Starlink represents the most significant example of civilian infrastructure becoming strategic military assets. Ukraine's military used Starlink terminals to coordinate drone attacks and maintain communication during the 2022 conflict, proving that commercial satellite constellations could determine battlefield outcomes. The Pentagon now considers Starlink a critical military resource, despite having no direct control over its operations or policies. When Elon Musk temporarily restricted Starlink access in certain regions during the Ukraine conflict, he demonstrated that private individuals could make decisions affecting military operations and international conflicts. Commercial satellite constellations like OneWeb, Amazon's Project Kuiper, and the planned Chinese Guoang system will control global communications infrastructure by 2027. These networks weren't designed as military assets, but they provide capabilities that nation-states consider essential for national security. Any company controlling global communications, satellites wields power that traditionally belonged only to governments. The Chinese government has already indicated they view foreign satellite constellations as potential threats to national security, while the United States has implemented export controls to prevent American satellite technology from being used by potential adversaries. Private military space contractors operate in regulatory gray areas that traditional oversight mechanisms weren't designed to address. Companies like Maxar Technologies provide satellite imagery to both commercial clients and intelligence agencies, making it impossible to distinguish between civilian Earth observation and military reconnaissance missions. Planet Labs operates over 200 small satellites that can monitor any location on Earth with daily revisit capabilities, providing intelligence-gathering capabilities that surpass many national intelligence agencies. These companies sell their services to whoever can pay, creating situations where competing nations might purchase surveillance data on each other from the same commercial provider. The traditional military-industrial complex assumed government agencies would control military space assets through established procurement processes and oversight mechanisms. Silicon Valley disrupted this model by developing space capabilities through private investment in commercial markets rather than government contracts. Companies like SpaceX reduced launch costs by 90% compared to traditional military contractors, forcing established defense companies to completely restructure their space programs. Boeing, Lockheed Martin, and Northrop Grumman now compete with companies that didn't exist 20 years ago and operate under completely different business models. Tech billionaires have accumulated space-based power that rivals nation-states through private ownership of critical space infrastructure. Elon Musk controls more satellites than most countries and can influence global communications through Starlink operational decisions. Jeff Bezos owns Blue Origin, which manufactures rocket engines for both commercial and military launches, giving him influence over national security space missions. These individuals make business decisions about space operation that affect international relations and military capabilities, but they answer to shareholders rather than elected officials or international treaties. The boundaries between civilian and military space operations have become impossible to distinguish in practical terms. Commercial satellite operators provide services to both civilian and military customers using identical technology and infrastructure. GPS systems serve civilian navigation needs and guide military precision weapons using the same satellites and ground control systems. Whether satellites support both agricultural planning and military mission planning through identical data collection and distribution systems. International law governing space militarization was written for an era when only nation-states could access space, and military space assets were clearly distinguishable from civilian systems. The Outer Space Treaty of 1967 prohibits placing weapons of mass destruction in orbit and claims of territorial sovereignty in space, but it doesn't address private companies controlling military-capable space assets or dual-use technologies that serve both civilian and military purposes. Current space law has no mechanisms for regulating private military contractors operating in space or preventing commercial satellites from being used for military purposes. Private companies now launch satellites monthly without disclosing their full capabilities or intended uses to international monitoring organizations. Commercial satellite operators can modify their system software to provide military capabilities without physically changing the hardware, making it impossible for treaty verification systems to monitor compliance with space militarization agreements. The emergence of non-state actors with space warfare capabilities has fundamentally altered the strategic landscape in ways that military planners are still struggling to understand. But while private companies and emerging nations scramble to establish conventional space capabilities, A revolutionary technology is already transforming the battlefield in ways that make traditional satellites look primitive by comparison. Quantum satellites and the new battlefield. Quantum communication satellites operating in Earth orbit right now can transmit data that remains completely secure from any interception attempt, no matter how sophisticated the enemy's technology becomes. These systems rely on quantum entanglement, a physical phenomenon where particles become connected in ways that make eavesdropping mathematically impossible. When someone tries to intercept a quantum encrypted message, the very act of observation changes the quantum state of the particles, immediately alerting both sender and receiver that their communication has been compromised. Military commanders can now send battle plans, troop movements, and strategic intelligence through space-based networks that enemy forces cannot crack, decode, or even successfully intercept without detection. China launched their first operational quantum communication satellite, MISSIS, in 2016, but their current quantum satellite constellation includes 17 active platforms providing secure communication coverage across Asia, Africa, and parts of Europe. Chinese military units can coordinate operations across multiple continents using quantum encrypted channels that American, Russian, and European intelligence agencies cannot penetrate. When Chinese naval forces conduct exercises in the South China Sea, their command communications travel through quantum satellite links that make traditional electronic warfare countermeasures completely ineffective. The People's Liberation Army can transmit submarine positions, aircraft deployment orders, and missile targeting data through quantum channels that remain secure, even when enemy forces know exactly which satellites are carrying the communications. The United States Space Force allocated $3.2 billion in emergency funding during 2024 to accelerate their quantum space communications program, originally scheduled for initial deployment in 2029, but now targeting operational capability by late 2026. American quantum satellite development focuses on creating redundant networks that can maintain secure communications even if multiple satellites are destroyed or disabled. The European Union established the Quantum Technologies Flagship Program with €1.5 billion in funding to develop independent quantum communication capabilities, recognizing that reliance on American or Chinese quantum networks creates unacceptable strategic vulnerabilities. Quantum radar satellites can detect stealth aircraft and submarines that remain invisible to conventional radar systems by using quantum-entangled photons to create detection capabilities that bypass traditional stealth technologies. Stealth aircraft achieve invisibility by absorbing or deflecting radio waves, but quantum radar systems can detect objects by measuring quantum correlations that stealth coatings cannot affect. Chinese quantum radar satellites launched in 2023 demonstrated the ability to track American F-35 Lightning II fighters and B-2 Spirit bombers during routine training flights over the Pacific Ocean. Russian quantum radar development programs received emergency funding increases after intelligence reports confirmed that Chinese quantum satellites could detect their Su-57 stealth fighters and nuclear submarines operating in international waters. Traditional satellites operating with classical encryption systems face complete vulnerability to quantum-enhanced cyber attacks that can break their security protocols within hours rather than the years or decades required by conventional computing methods. Quantum computers can solve the mathematical problems that protect current satellite communications by testing multiple solutions simultaneously through quantum superposition. Military satellites launched before 2020 use RSA encryption that quantum computers can defeat, making them defenseless against nations possessing operational quantum computing capabilities. The National Security Agency issued classified warnings in 2024 that existing military satellite networks could be compromised by quantum attacks within the next 3 years. Quantum entanglement enables instantaneous communication across distances spanning millions of kilometers, allowing Earth-based command centers to maintain real-time control over spacecraft operating near the Moon, Mars, or in the asteroid belt. Traditional radio communications require increasing amounts of time to travel between Earth and distant spacecraft, creating delays that make real-time military coordination impossible. Quantum-entangled particles maintain their connection regardless of distance, enabling military commanders to send orders to lunar bases or asteroid mining operations, without the communication delays that currently limit deep space military operations. Quantum sensors deployed on military satellites can detect minute gravitational changes, electromagnetic emissions, and thermal signatures that reveal hidden underground installations, moving submarines, and camouflaged military equipment with precision impossible using conventional sensor technology. These sensors measure quantum fluctuations in spacetime itself, allowing them to detect massive objects like submarines or underground bunkers by their gravitational effects on quantum fields. Quantum sensors can identify individual aircraft by their unique electromagnetic signatures, track personnel movements inside buildings, and monitor industrial activity at levels of detail that make traditional camouflage and concealment techniques obsolete. The quantum communication arms race accelerated dramatically after China demonstrated operational quantum satellite capabilities during military exercises in 2023, prompting immediate responses from the United States, Russia, and European Union to prevent Chinese dominance in secure military communications. Russian military spending on quantum space programs increased by 340% between 2023 and 2024, with crash development programs targeting operational deployment by 2027. American defense contractors received emergency authorizations to begin manufacturing quantum communication satellites using expedited procurement processes that bypass normal testing and evaluation requirements. Quantum technology makes space-based command and control systems nearly immune to jamming, hacking, or other forms of electronic warfare that could disrupt military operations during conflicts. Traditional military communications can be jammed by broadcasting powerful radio signals that overwhelm receiver systems. But quantum communications cannot be disrupted by external interference because they rely on quantum mechanical properties rather than radio wave transmission. Enemy forces cannot jam quantum satellite communication, even if they know the exact frequencies and transmission methods being used. Nations achieving dominance in quantum satellite technology will possess communication advantages comparable to having radios when enemies rely on signal flags, or having encrypted telegraph systems when opponents use unprotected postal mail. Quantum satellites represent the ultimate strategic high ground in modern warfare because they provide capabilities that enemy forces cannot counter using conventional technology. The first military force to deploy comprehensive quantum satellite networks will possess secure communications, undetectable reconnaissance, and cyber warfare capabilities that their opponents cannot match or effectively counter through any existing military technology. But even the most sophisticated quantum encryption and detection systems require human operators to analyze threats, make decisions, and authorize responses. The speed of space combat and the complexity of managing hundreds of satellites simultaneously has pushed military planners toward a solution that eliminates human decision-making delays entirely. AI commanders in the void. Autonomous artificial intelligence systems now control military satellites that make targeting and engagement decisions without human authorization, processing threats and executing responses in milliseconds, while human operators remain unaware that combat actions have occurred. These AI systems analyze incoming data from multiple sensors, identify potential threats using machine learning algorithms, calculate optimal response strategies, and deploy countermeasures faster than any human commander could recognize that a threat exists. Military satellites equipped with AI decision-making systems can detect, track, and engage hostile spacecraft or incoming projectiles within 0.3 seconds of initial contact, while traditional human-controlled systems require 15 to 30 seconds for threat assessment and response authorization. Machine learning algorithms process space-based sensor data at rates exceeding 50 terabytes per second, identifying patterns in satellite movements, electromagnetic emissions, and orbital mechanics that human analysts would require weeks or months to recognize. AI systems simultaneously monitor thousands of objects across multiple orbital planes, tracking their positions, velocities, and operational status, while predicting future movements with accuracy levels approaching 99.7%. These algorithms learn from every satellite maneuver, communication burst, and orbital adjustment, building comprehensive databases of normal and abnormal space operations that enable them to detect hostile actions within minutes of initiation. The United States Space Force deployed Operation Cerberus in late 2024, consisting of 12 AI-controlled satellites operating in coordinated swarms that execute complex military maneuvers without ground control oversight. Each satellite in the swarm shares real-time data with other units through encrypted mesh networks, allowing the entire formation to adapt their positions and responses based on collective intelligence rather than individual sensor readings. These AI swarms can reconfigure their orbital formations, redistribute defensive coverage, and coordinate attack patterns against multiple targets simultaneously, while maintaining formation integrity, even if several units are destroyed or disabled. China's Tianlong AI system demonstrated predictive capabilities during classified exercises in September 2024, accurately forecasting American reconnaissance satellite movements 72 hours in advance and preemptively positioning defensive assets to block potential surveillance attempts. The system analyzed historical orbital data, communication patterns, and operational schedules to predict when and where American satellites would conduct intelligence-gathering operations, then moved Chinese military satellites into positions that would interfere with or prevent successful reconnaissance missions. Russian military satellites have exhibited similar predictive behavior, suggesting that multiple nations have developed AI systems capable of anticipating enemy space operations and positioning their assets accordingly. Artificial intelligence systems aboard hostile satellites engage in autonomous battles occurring in Earth orbit every day, executing attack and defense sequences that human operators discover only after reviewing post-mission data logs. These AI versus AI encounters involve electronic warfare attacks, kinetic interception attempts, and orbital maneuvering duels where opposing systems attempt to outmaneuver each other while maintaining their operational objectives. Chinese and American military satellites have conducted dozens of autonomous engagements since March 2024, with AI systems on both sides learning from each encounter and developing increasingly sophisticated tactics for future confrontations. Space surveillance operations now rely entirely on artificial intelligence systems that monitor orbital activity 24 hours per day across all altitude ranges from low Earth orbit to geosynchronous positions 35,786 kilometers above the equator. These AI systems track over 34,000 objects larger than 10 centimeters, predict collision risks, identify potentially hostile activities, and alert human operators to situations requiring immediate attention. The European Space Surveillance and Tracking System processes over 2.3 million sensor readings daily through machine learning algorithms that can distinguish between natural space debris, operational satellites, and potential weapons systems based on their movement patterns and electromagnetic signatures. Ground-based space control centers now serve primarily as monitoring stations for AI systems that make most operational decisions independently, with human operators intervening only when AI systems request specific authorization or when situations exceed predetermined parameters. Military satellites equipped with artificial intelligence can modify their orbits, adjust their sensor configurations, deploy defensive countermeasures, and coordinate with other AI-controlled assets without requiring approval from human commanders. These systems submit operational reports to ground control after completing their missions, rather than requesting permission before taking action. The risk of AI systems escalating space conflicts beyond human control became apparent during a classified incident in November 2024, when autonomous defense systems aboard multiple nations, satellites simultaneously identified each other as threats and began executing attack sequences that required direct intervention from heads of state to prevent space warfare from beginning inadvertently. Military AI systems had calculated that preemptive strikes offered the highest probability of mission success and began preparing kinetic attacks against enemy satellites before human operators realized that their AI systems were interpreting routine orbital maneuvers as hostile actions. Chinese AI systems demonstrate superior learning capabilities compared to American and Russian artificial intelligence platforms, processing space surveillance data 40% faster and predicting enemy satellite behavior with 15% greater accuracy than competing systems. Chinese machine learning algorithms benefit from access to comprehensive databases of global satellite operations, collected through their extensive space surveillance networks and cyber intelligence operations. The People's Liberation Army has invested over $8 billion specifically in AI development for space warfare applications, creating systems that can simultaneously coordinate hundreds of military satellites while learning from every encounter with foreign space assets. Military artificial intelligence systems now possess decision-making authority over space assets, worth hundreds of billions of dollars, and weapon systems capable of disabling global communications, navigation, and surveillance infrastructure within hours. These AI systems can initiate conflicts, escalate tensions, and execute military operations that affect billions of people on Earth. Yet they operate according to algorithms that even their creators cannot fully predict or control. The next major space conflict may begin not because human leaders decide to go to war, but because artificial intelligence systems conclude that preemptive attack offers the optimal solution to perceived threats. But these AI systems operate in a legal vacuum, where the rules governing their actions were written decades before their existence was even imagined. The crumbling space treaties. The Outer Space Treaty of 1967 faces systematic dismantling as major powers exploit its outdated language to justify military space programs that would have been unthinkable when the treaty was written. Russia announced in February 2024 that their Cosmos military satellites qualify as peaceful exploration missions because they conduct scientific observations alongside their weapons targeting capabilities. China declared their orbital kinetic weapons platforms serve peaceful purposes by removing dangerous space debris through controlled destruction of defunct satellites. The United States Space Force classified their offensive satellite systems as defensive research projects, arguing that developing counterspace weapons prevents other nations from achieving space dominance. Nations have violated or reinterpreted space law through creative definitions that render treaty language meaningless while maintaining technical compliance with international agreements. Russia deployed nuclear-powered satellites in 2024 that they described as peaceful energy research platforms, despite these systems containing nuclear reactors capable of powering directed energy weapons or electromagnetic pulse generators. China launched military satellites under commercial designations, registering weapons platforms as communication satellites with the International Telecommunication Union, while equipping them with kinetic interceptors and cyber warfare capabilities. The United States established Space Force bases that they classify as research installations rather than military facilities, allowing them to station weapons systems on the Moon and in Earth orbit, while claiming compliance with treaty provisions prohibiting military installations in space. European nations have registered military reconnaissance satellites as Earth observation missions for climate research, using environmental protection as legal cover for intelligence-gathering operations that violate the spirit of peaceful space exploration. The definition of peaceful purposes has stretched beyond recognition, as military planners discovered that almost any weapon system can be justified as serving defensive or scientific objectives. Orbital missile platforms become asteroid defense systems in official documentation. Space-based laser weapons transform into debris removal tools in treaty compliance reports. Nuclear-powered military satellites receive classification as clean energy research projects. Anti-satellite weapons systems appear in international filings as space traffic management tools designed to prevent orbital collisions. Military space programs exploit legal loopholes that allow weapons deployment while maintaining technical treaty compliance through careful interpretation of ambiguous language written decades before current technology existed. The Outer Space Treaty prohibits placing weapons of mass destruction in orbit, but says nothing about conventional weapons, kinetic interceptors, directed energy systems, or cyber warfare platforms. Nations deploy satellite swarms equipped with conventional explosives, arguing that individual satellites don't qualify as weapons of mass destruction, even when coordinated swarms can disable entire orbital infrastructures. Private companies operate in legal gray areas that place them beyond traditional space law oversight, because the Outer Space Treaty was written for an era when only governments could access space. Article VI requires authorization and continuous supervision of non-governmental entities, but the interpretation of this provision remains contested, with some arguing it only includes intergovernmental organizations while excluding private actors from treaty oversight entirely. SpaceX operates military-capable satellites under commercial licenses that don't require disclosure of defensive systems or dual-use capabilities. Blue Origin manufactures rocket engines for both civilian and military applications through the same production facilities, making it impossible to distinguish between peaceful and military hardware. Private military contractors launch weapons systems using commercial space transportation services, creating situations where civilian companies unknowingly participate in space militarization, while maintaining plausible deniability about their cargo's military applications. The U.S. Commercial Space Launch Competitiveness Act of 2015 promotes commercial exploration and resource recovery, fostering a pro-growth environment that makes regulation nearly impossible. This act, combined with the U.S.-led Artemis Accords signed by 21 countries, encourages commercial activity by private actors, while creating regulatory gaps that military contractors exploit to deploy weapons systems under civilian oversight frameworks. International bodies have failed to adapt space law to modern realities, as the United Nations Office for Outer Space Affairs operates with the same legal frameworks established in 1967. The Committee on the Peaceful Uses of Outer Space meets twice yearly to discuss space law updates, but has produced no binding agreements on military space activities, private company regulation, or weapons deployment restrictions since the original treaty was signed. Dual-use technology makes treaty enforcement nearly impossible because the same systems that provide civilian benefits can serve military purposes without hardware modifications. Communication satellites relay both civilian internet traffic and encrypted military communications through identical transponders. Earth observation satellites collect agricultural data and military intelligence using the same sensor systems. Navigation satellites provide civilian GPS services and guide precision weapons through identical signal processing equipment. Nations can modify satellite software to activate military capabilities without changing physical hardware, making verification of treaty compliance impossible through traditional monitoring methods. Commercial satellites launched for civilian purposes can receive software updates that transform them into military assets within hours of upload completion. Private companies can lease satellite bandwidth to military customers without disclosing the nature of communications being transmitted through their civilian-registered spacecraft. International cooperation in space governance has collapsed as nations prioritize national security over collaborative oversight mechanisms. The European Union withdrew from joint space monitoring agreements with Russia following the Ukraine conflict. China stopped sharing orbital data with American space tracking networks after trade disputes escalated. The United States classified previously public information about military satellite capabilities, preventing international verification of treaty compliance. Attempts to create new space warfare regulations have failed because major space powers refuse to accept limitations on their military capabilities, while potential adversaries continue developing weapons systems. Russia and China submitted a draft prevention of placement of weapons in outer space treaty to the Conference on Disarmament, but Western nations rejected it as propaganda designed to prevent American space defense systems, while allowing continued development of Chinese and Russian space weapons. Space has become a lawless frontier where military might determine operational boundaries rather than international agreements or diplomatic negotiations. Nations deploy weapons systems in Earth orbit while filing paperwork that describes them as peaceful research projects. Private companies launch military hardware using civilian regulatory frameworks designed for commercial satellites. Military commanders make operational decisions about space assets based on strategic advantage rather than treaty compliance, knowing that enforcement mechanisms don't exist and international courts have no jurisdiction over orbital activities. But the most dangerous weapons in space may not be the sophisticated systems that nations spend billions developing. Sometimes the deadliest threats come from the most unexpected sources. Space debris as the ultimate weapon. A paint fleck the size of a grain of sand traveling at 17,500 miles per hour through Earth orbit carries enough kinetic energy to punch through solid steel plating and destroy a billion-dollar satellite on impact. Multiply that destructive potential by the 34,000 trackable pieces of space debris currently circling our planet, plus an estimated 900,000 smaller fragments between 1 and 10 centimeters that space tracking systems cannot monitor, and the scope of this orbital weapons cache becomes clear. Military strategists have recognized that space junk represents the ultimate distributed weapons system, scattered across every orbital altitude and ready for deployment by any nation possessing the technology to redirect debris trajectories toward enemy targets. Russia demonstrated debris redirection capabilities during classified exercises in August 2024, when their orbital maneuvering vehicles successfully altered the trajectory of 3 defunct satellite fragments, steering them into controlled impacts with designated test targets in low Earth orbit. The Russian space forces used ion propulsion systems mounted on small spacecraft to nudge space debris onto collision courses, with precise timing calculations that placed impact events within 0.3 seconds of predicted schedules. Chinese military satellites have exhibited similar debris manipulation capabilities, deploying electromagnetic tethers to capture small fragments and redirect them toward predetermined orbital zones where enemy reconnaissance satellites operate on predictable schedules. The European Space Agency's Space Debris Office tracks over 130 million objects smaller than 1 centimeter in Earth orbit, creating a comprehensive database that military planners now use for targeting rather than collision avoidance. These microdebris clouds can be weaponized through deployment systems that release millions of particles into specific orbital paths where enemy satellites will encounter them during routine operations. Nations can deploy microdebris swarms that create permanent no-go zones across entire orbital altitudes, denying adversaries access to critical communication, relay positions, or reconnaissance vantage points, without technically violating international treaties prohibiting weapons deployment in space. Military forces can trigger Kessler syndrome deliberately by targeting satellites in densely populated orbital regions, where debris from a single destruction event will cascade into multiple secondary collisions, creating exponentially expanding debris fields that render entire orbital altitudes unusable for decades. Computer simulations conducted by the Defense Advanced Research Projects Agency show that destroying just 12 strategically selected satellites in low Earth orbit could generate debris cascades affecting over 3,000 additional space assets within 6 months. The deliberate triggering of Kessler syndrome represents an ultimate denial weapon that could end space access for all nations while providing strategic advantage to the country that triggers the cascade last. Space tracking networks, originally designed to protect operational satellites from collision hazards, have evolved into targeting systems that provide real-time location data for enemy satellites while identifying optimal debris intercept opportunities. The United States Space Surveillance Network processes over 500,000 observations daily through a global array of ground-based radars and optical telescopes that can track objects as small as 5 centimeters across all orbital altitudes. This same tracking infrastructure enables military planners to calculate precise trajectory modifications needed to redirect existing debris toward specific enemy satellites, transforming defensive monitoring systems into offensive targeting networks. Military contractors have developed clean kinetic weapons designed to destroy enemy satellites while producing minimal trackable debris that could endanger other space assets or create long-term orbital hazards. These systems use focused energy impacts or controlled fragmentation techniques that vaporize target satellites into particles too small for ground-based tracking systems to monitor. Lockheed Martin's classified kinetic interceptor program produces impact effects that fragment target satellites into pieces smaller than 2 centimeters, reducing the risk of cascading collisions while maintaining plausible deniability about whether satellite failures resulted from deliberate attacks or natural space hazards. The existing space debris environment provides perfect cover for anti-satellite attacks because collision events appear identical to accidental impacts from natural space junk when observed through ground-based monitoring systems. Military satellites destroyed by redirected debris fragments show impact signatures indistinguishable from random collision events, making attribution of responsibility nearly impossible through technical analysis alone. Intelligence agencies rely on circumstantial evidence like unusual orbital maneuvers by suspect spacecraft or suspicious timing of debris events to identify deliberate attacks rather than definitive physical proof that debris impacts were artificially directed. Technologies developed for debris mitigation and space cleanup missions possess dual-use capabilities that enable their conversion into weapons delivery systems capable of deploying kinetic interceptors or other hostile payloads against enemy satellites. Japan's space debris removal demonstration mission, scheduled for 2025, uses robotic arms and electromagnetic nets to capture defunct satellites, But the same systems could easily deploy explosive charges or kinetic projectiles against operational military targets. Switzerland's Clear Space 1 debris removal mission employs orbital maneuvering techniques and precision approach capabilities that could deliver weapons payloads to enemy satellites while maintaining the appearance of legitimate space cleanup operations. Our space junk problem has transformed into a loaded gun pointed directly at technological civilization, with trigger mechanisms distributed among multiple nations, possessing debris redirection capabilities and targeting systems sophisticated enough to convert orbital trash into precision weapons. The 9,000 tons of space debris currently orbiting Earth represents a weapons stockpile equivalent to thousands of kinetic interceptors, pre-positioned across every operational orbital altitude, and ready for deployment against any nation's satellite infrastructure. But orbital debris represents only the beginning of space militarization. Nations seeking permanent strategic advantage are already looking beyond Earth orbit to establish military dominance across the entire solar system, starting with humanity's closest celestial neighbor. The race for lunar military bases. China and Russia plan to establish permanent military installations on the Moon by 2030, marking the first time in human history that nations will deploy armed forces beyond Earth's atmosphere for territorial control rather than scientific exploration. The Chinese National Space Administration and Roscosmos signed classified agreements in 2024, detailing joint lunar base construction beginning with unmanned cargo deliveries in 2027, followed by permanent crew rotations starting in 2029. These installations will house military personnel, weapons systems, and surveillance equipment designed to monitor Earth-based activities and control access to lunar resources worth trillions of dollars. The China-Russia Lunar Base Partnership combines Chinese manufacturing capabilities with Russian heavy-lift rocket technology, creating a formidable alliance that challenges American space dominance through shared costs and expertise. Chinese factories produce standardized habitat modules, life support systems, and construction equipment specifically designed for lunar deployment, while Russian Angara rockets provide the heavy lift capacity needed to transport massive base components beyond Earth orbit. This collaboration allows both nations to establish lunar military presence years ahead of schedule, while splitting development costs that would exceed $200 billion for either country operating independently. Military applications of the joint lunar base become obvious when examining its planned infrastructure, including radar installations capable of tracking every satellite in Earth orbit, communication arrays that can intercept global telecommunications, and launch facilities designed for rapid deployment of space-based weapons systems. The base will incorporate underground bunkers capable of withstanding nuclear attacks, surface-to-space missile batteries for defending against incoming threats, and manufacturing facilities for producing weapons and equipment using lunar resources. Russian military doctrine explicitly identifies lunar installations as strategic assets for projecting power across the solar system and maintaining superiority over terrestrial adversaries. The Artemis Accords create legal frameworks that participating nations exploit to claim strategic lunar territory under the guise of scientific cooperation and resource extraction rights. 27 countries have signed these agreements, establishing operational zones around planned landing sites that effectively function as territorial claims despite international law prohibiting national appropriation of celestial bodies. The United States uses Artemis provisions to justify exclusive access to lunar South Pole regions containing water ice deposits essential for fuel production, while European Union members claim crater formations rich in rare earth elements needed for advanced electronics manufacturing. These territorial claims through the Artemis Accords establish precedents for military base construction by designating safety zones around civilian installations that could easily accommodate weapon systems and surveillance equipment. Nations can deploy military assets within Artemis operational zones, while maintaining legal cover through dual-use justifications that describe weapons systems as debris protection or emergency response equipment. The accords lack enforcement mechanisms for preventing military activities within civilian operational zones, creating opportunities for armed installations disguised as research facilities or mining operations. Moon-based weapons platforms offer decisive military advantages over Earth-based systems through positioning that enables global target coverage, reduced launch energy requirements, and immunity from terrestrial countermeasures. Lunar installations can maintain continuous surveillance of Earth's entire surface through orbital mechanics that provide complete hemispheric coverage every 12 hours, allowing military commanders to monitor enemy activities across all continents simultaneously. Weapons launched from lunar bases benefit from the Moon's reduced gravity, requiring minimal energy to achieve escape velocity while maintaining precision targeting capabilities against Earth-based targets. Surveillance systems deployed on lunar military bases can monitor radio communications, track aircraft and naval vessel movements, and observe ground-based military activities with resolution capabilities exceeding current satellite reconnaissance systems. The Moon's airless environment eliminates atmospheric interference that degrades Earth-based optical and radar systems, enabling lunar telescopes and sensor arrays to achieve observation capabilities impossible from terrestrial installations. Military commanders operating lunar surveillance networks can coordinate global intelligence gathering operations while remaining beyond the reach of Earth-based anti-satellite weapons or cyber attacks. Lunar mining operations require military protection from the outset because extracted resources like helium-3, rare earth elements, and water ice represent strategic assets worth hundreds of billions of dollars that nations cannot risk losing to competitors or saboteurs. Mining equipment transported to the Moon costs thousands of dollars per kilogram, making these installations extraordinarily valuable targets that justify permanent military garrison deployment. Processing facilities that convert lunar materials into rocket fuel, construction materials, and manufactured goods create industrial capabilities that participating nations will defend through armed force if necessary. The Moon's reduced gravity allows construction of weapons systems impossible to deploy on Earth, including massive railguns, particle beam generators, and kinetic launchers that require enormous structural supports and power systems that terrestrial installations cannot accommodate. Military engineers can construct weapons platforms weighing thousands of tons using locally manufactured materials and assembly techniques adapted to lunar conditions. These massive installations can generate power levels and launch projectiles at scales that dwarf anything achievable through Earth-based military systems. The potential for extraterrestrial territorial conflict increases as multiple nations establish competing lunar bases within proximity of valuable resource deposits or strategically important locations like the lunar South Pole. Territorial disputes that begin as disagreements over mining rights or operational zone boundaries could escalate into armed confrontations between military forces operating hundreds of thousands of kilometers from Earth. The first extraterrestrial war may begin over conflicting claims to lunar territory, with battles fought using weapons and tactics specifically adapted to airless, low-gravity combat conditions. Lunar bases function as ideal staging areas for military operations extending deeper into the solar system, where even greater concentrations of wealth await extraction by nations possessing the technological capabilities and military strength to claim and defend these resources. The Moon's gravitational advantages enable spacecraft launched toward distant targets to carry larger payloads and heavier weapons systems than missions originating from Earth. Nations achieving dominance over lunar territory may ultimately control Earth's economic and military future through their ability to deny space access to competitors, monopolize extraterrestrial resources, and deploy weapons systems that render terrestrial military forces obsolete. But the moon represents only the beginning of this resource competition, as humanity's attention turns toward prizes that dwarf even the most optimistic projections of lunar wealth. Asteroid mining wars on the horizon. A single metallic asteroid designated 16 Psyche contains an estimated $10,000 quadrillion worth of iron, nickel, and precious metals, including more platinum than humanity has extracted from Earth's crust throughout recorded history. This asteroid alone could supply global platinum demand for millions of years at current consumption rates, while hundreds of similar metallic asteroids orbit within the main asteroid belt between Mars and Jupiter. NASA's Psyche mission, launched in October 2023, will reach this metallic world by 2029 and provide detailed mapping of resources that could fundamentally reshape global economics and trigger the first extraterrestrial resource wars in human history. The creation of the first trillionaires will occur not through terrestrial business ventures, but through asteroid mining operations that access resources worth more than the combined gross domestic product of every nation on Earth. Companies like Planetary Resources and Deep Space Industries have identified over 9,000 near-Earth asteroids containing precious metals, rare earth elements, and water ice deposits that could generate individual fortunes exceeding $1 trillion within decades of successful extraction operations beginning. These vast wealth concentrations will destabilize existing economic systems as asteroid-derived materials flood global markets and crash commodity prices that have remained stable for centuries. Traditional mining companies face extinction when asteroid-derived platinum, gold, and rare earth elements reach Earth markets in quantities that make terrestrial extraction economically obsolete. South African platinum mines, Chilean copper operations, and Chinese rare earth processing facilities represent investments worth hundreds of billions of dollars that become worthless overnight when space-based alternatives deliver identical materials at fractions of current production costs. Entire national economies built around natural resource extraction will collapse as asteroid mining operations bypass traditional supply chains and distribution networks that have supported millions of jobs across multiple continents. Military implications of unlimited raw materials available through asteroid mining operations extend far beyond economic disruption into strategic advantages that could determine global power balances for centuries. Nations controlling asteroid mining capabilities can produce unlimited quantities of titanium for aircraft construction, rare earth elements for advanced electronics, and platinum for military sensors without depleting terrestrial reserves or depending on foreign suppliers. The United States military consumes over 750,000 tons of raw materials annually for weapons manufacturing, vehicle production, and infrastructure construction, costs that become negligible when asteroid resources provide unlimited supplies of every element needed for military operations. Asteroid mining operations incorporate defensive capabilities from initial design phases because extracted resources represent strategic assets worth protecting through armed force against competitors, saboteurs, and hostile government seizure attempts. Mining platforms operating near asteroids like Bennu or Ryugu will mount kinetic interceptors, electromagnetic pulse generators, and precision laser systems capable of destroying approaching spacecraft from distances exceeding 10,000 kilometers. Defensive installations protect mining equipment worth billions of dollars, processed materials awaiting transport to Earth, and industrial facilities that represent decades of investment in space-based manufacturing capabilities. China's national space policy identifies asteroid mining as essential for long-term economic dominance, with classified military documents outlining plans to establish armed mining operations throughout the asteroid belt by 2045. Chinese asteroid mining operations will deploy military escorts, fortified processing stations, and defensive satellite networks designed to exclude competitors from valuable resource extraction sites. The European Space Agency received emergency funding increases in 2024, specifically for military space programs designed to protect future European asteroid mining investments from Chinese or American seizure attempts. Control over key asteroids will determine which nations dominate the 22nd century through their ability to access unlimited raw materials while denying these resources to potential adversaries. The asteroid Vesta contains enough rare earth elements to supply global electronics manufacturing for thousands of years, making it a strategic prize worth fighting multiple wars to control. Ceres holds billions of tons of water ice that can be converted into rocket fuel, enabling the nation controlling this dwarf planet to dominate space transportation and military logistics throughout the solar system. Mobile asteroid fortresses represent the inevitable evolution of mining platform defensive systems as operations expand beyond individual asteroids into comprehensive resource extraction networks spanning the entire asteroid belt. These massive installations combine mining equipment, weapons systems, manufacturing facilities, and crew quarters into self-sufficient military bases capable of independent operations for decades without resupply from Earth. Asteroid fortresses can relocate between resource sites using ion propulsion systems, establishing temporary mining operations while maintaining defensive capabilities against hostile forces operating in nearby space. Corporate wars over asteroid claims become inevitable as private companies invest trillions of dollars in mining operations that governments cannot regulate or protect through existing international law. SpaceX, Blue Origin, and Planetary Resources will deploy private military contractors to defend their asteroid mining claims against competitors seeking to establish overlapping extraction operations. These corporate conflicts will involve armed spacecraft, sabotage operations against rival mining platforms, and cyber attacks designed to disrupt competing companies' operations while protecting proprietary mining technologies and resource extraction sites. Asteroid redirect technology developed for mining operations possesses dual-use capabilities that transform these systems into planet-killing weapons capable of devastating Earth through controlled asteroid impacts. The same propulsion systems used to move asteroids toward processing facilities can redirect these massive objects toward Earth, creating kinetic impacts with destructive potential exceeding nuclear weapons. Nations controlling asteroid redirect capabilities possess ultimate deterrent weapons that could eliminate entire continents, while maintaining plausible deniability about whether asteroid impacts resulted from deliberate attacks or navigation system failures. The asteroid belt represents humanity's most contested battlefield because control over these resources determines which civilizations survive and prosper throughout the 22nd century, while others face economic collapse and technological stagnation. Military conflicts in the asteroid belt will involve robotic forces, automated weapons systems, and artificial intelligence commanders operating across distances that make real-time human control impossible. But these distant resource wars may seem insignificant compared to what happens when space warfare finally reaches Earth orbit itself. The 2050 scenario, when space war goes hot. The cascade begins with a single misidentified cargo vessel at 3:47 GMT on October 15, 2054, when automated defense systems aboard the Chinese orbital platform Tiangong-12 detect what their algorithms classify as an imminent kinetic threat approaching from American lunar installations. Within 0.8 seconds, The AI system initiates defensive protocols programmed to prioritize platform survival over diplomatic considerations. Tiangong 12 autonomous weapons array launches 17 kinetic interceptors toward what turns out to be a routine supply shipment heading to the International Space Station. The cargo vessel's destruction triggers cascade protocols across military satellite networks belonging to 6 different nations, each system interpreting the attack as evidence that space warfare has begun. By 3:52 GMT, autonomous satellite swarms from the United States, China, Russia, and the European Union are maneuvering into attack formations, while their human commanders remain completely unaware that the first space war has started. American defensive satellites respond to the cargo vessel's destruction by deploying electromagnetic pulse charges that disable 43 Chinese communication satellites within 12 minutes of the initial incident. Chinese AI systems interpret this response as confirmation of American aggression and activate dormant weapons systems hidden throughout their civilian satellite constellation. Russian military satellites detect the expanding electromagnetic signatures and assume both American and Chinese forces are targeting their assets, triggering automated responses that destroy 6 European navigation satellites and 14 commercial communication platforms operated by private companies. The European Space Defense Network activates its distributed satellite swarm, consisting of 300 small interceptor platforms disguised as routine Earth observation missions for over a decade. These platforms coordinate their attacks through quantum-encrypted networks that operate faster than human oversight can monitor or intervene. Within 47 minutes of the initial incident, over 400 military and civilian satellites have been destroyed or disabled across multiple orbital altitudes, creating debris clouds that immediately threaten every operational spacecraft in Earth orbit. Ground-based infrastructure begins failing within 2 hours as GPS signals disappear across North America, Europe, and Asia simultaneously. Commercial aviation systems lose navigation capabilities, forcing emergency landings for over 8,000 aircraft worldwide. Container ships carrying international cargo find themselves unable to navigate coastal waters without satellite positioning systems. Financial markets collapse as trading networks dependent on satellite communications go offline, erasing trillions of dollars in global wealth before emergency backup systems can restore basic functionality. Global communication networks fragment as military forces destroy civilian satellites to prevent enemy intelligence gathering operations. Internet services relying on satellite connectivity disappear across rural areas and developing nations that lack extensive fiber optic infrastructure. Emergency services lose communication capabilities as first responders find their radios and cellular networks disabled by satellite destruction. Weather forecasting systems go blind as meteorological satellites join the growing debris fields, leaving billions of people without advance warning of approaching storms and natural disasters. Space-based solar power stations become primary targets as military planners recognize their strategic importance for maintaining terrestrial electrical grids during extended conflicts. The European Solar Power Consortium's orbital installations generate 340 gigawatts of clean electricity for distribution to Earth through microwave power transmission systems. Chinese kinetic weapons destroy the primary power transmission satellites within 6 hours of combat beginning, immediately cutting electrical power to 200 million people across Europe and triggering rolling blackouts that cascade through interconnected power grids. American forces retaliate by targeting Chinese solar power installations, eliminating 180 gigawatts of generating capacity and plunging eastern China into darkness. The destruction of power transmission systems creates positive feedback loops that accelerate infrastructure collapse as backup generators run out of fuel and nuclear power plants initiate emergency shutdowns, to prevent meltdowns during grid instability. Hospital emergency systems fail when backup power supplies are exhausted, while water treatment facilities stop operating without electrical power to run pumping and filtration systems. Transportation networks grind to a halt as electric trains lose power and fuel distribution systems depend on satellite-controlled logistics networks that no longer exist. Space elevators operating from equatorial platforms in Ecuador, Kenya, and Indonesia become strategic choke points that military forces fight desperately to control or destroy. These massive structures enable low-cost transportation of materials and personnel between Earth's surface and orbital installations, making them essential for maintaining military operations in space. Russian submarine-launched ballistic missiles target the Ecuadorian space elevator's ground terminus, severing the carbon nanotube tether and causing the orbital counterweight to spin away into deep space, while the lower portion crashes across 2,000 kilometers of South American territory. Lunar military installations launch kinetic bombardment systems toward Earth orbit conflict zones, adding long-range artillery support that arrives with devastating precision 48 hours after launch. Chinese lunar bases fire tungsten projectiles weighing 500 kilograms each toward American satellite clusters, while American lunar installations respond with similar attacks against Chinese orbital assets. These massive projectiles travel at velocities exceeding 15 kilometers per second when they reach Earth orbit, creating explosions equivalent to tactical nuclear weapons, while producing electromagnetic pulses that disable nearby satellites. Space debris generated by the first 72 hours of combat creates permanent exclusion zones across altitudes from 200 to 2,000 kilometers above Earth's surface. Computer simulations indicate that debris density has exceeded safe operational thresholds for spacecraft navigation, effectively ending human access to space for the foreseeable future. The Kessler syndrome cascade triggered by military action will continue generating secondary collisions for decades, creating expanding debris clouds that make satellite operations impossible and trap humanity on Earth's surface. The realization emerges within a week that space warfare represents an existential threat to technological civilization, because modern society depends entirely on satellite-based systems for basic functionality. Without GPS navigation, weather forecasting, global communications, and orbital manufacturing capabilities, human civilization faces collapse into pre-industrial conditions, while recovery remains impossible due to the permanent debris barriers preventing future space access. But this catastrophic scenario assumes humanity remains confined to a single star system, limited by the energy output of one sun and the resources of a handful of planets. Beyond 2100, the Kardashev scale of space warfare. Military technology advances beyond current human comprehension when civilizations harness the complete energy output of their home star. A Type II civilization on the Kardashev scale can capture and direct the equivalent of 400 trillion watts continuously, representing more energy than humanity has consumed throughout our entire existence as a species. When these civilizations turn their stellar-scale power sources toward warfare, individual battles involve energy releases exceeding the total output of our sun for extended periods, creating weapon systems that operate on scales currently beyond human understanding. Dyson spheres constructed around stars become both ultimate energy sources and devastating weapons platforms when controlled by military forces spanning multiple star systems. These massive structures capture stellar radiation through arrays of collectors orbiting at various distances from their host stars. But military engineers can reconfigure these same systems to focus concentrated starlight into directed energy beams, capable of sterilizing entire planets from distances measured in light years. The construction materials required for military Dyson spheres exceed the mass of hundreds of Earth-sized planets. Yet civilizations operating at Type II energy levels can harvest and process such quantities of matter through automated manufacturing systems that treat entire asteroid belts as raw material stockpiles. Stellar engineering projects transform stars themselves into weapons through techniques that manipulate nuclear fusion processes, magnetic field configurations, and stellar mass distribution to create controlled energy releases directed toward enemy civilizations. Military engineers operating at cosmic scales can trigger stellar flares aimed at specific target systems, induce premature supernova explosions that eliminate entire stellar neighborhoods, or construct artificial black holes that serve as gravitational weapons capable of disrupting planetary orbits across multiple star systems. The manipulation of stellar evolution represents the ultimate expression of military technology because it converts the fundamental processes that power galaxies into targeted weapon systems. Interstellar distances spanning dozens or hundreds of light years create strategic challenges that render traditional concepts of warfare obsolete through the physics of space and time. Military campaigns conducted across such vast distances require planning horizons extending centuries into the future, with attack orders transmitted to forces that may not receive their instructions for decades after political situations have changed completely. Even traveling at 10% of light speed, military expeditions require 42 years to reach Proxima Centauri, humanity's nearest stellar neighbor, creating operational timelines that exceed the lifespans of individual human commanders and political systems that authorize military actions. Communication delays inherent in interstellar warfare mean that battlefield commanders operate with intelligence that becomes obsolete decades before enemy responses can be observed or countered. Military forces dispatched toward enemy star systems must function as completely autonomous entities because real-time coordination with home civilizations becomes impossible across interstellar distances. Strategic decisions made by civilizations separated by hundreds of light years create cascading consequences that unfold over geological time scales, potentially triggering conflicts that continue for millennia after their original causes have been forgotten. Uploaded consciousness and advanced artificial intelligence systems eliminate human soldiers entirely from military operations conducted across cosmic distances, replacing biological limitations with digital entities capable of operating effectively across the centuries required for interstellar campaigns. AI military commanders can maintain strategic continuity across multiple human lifespans while processing intelligence data and coordinating military operations at speeds that biological minds cannot match. Digital consciousness transferred between spacecraft, orbital installations, and planetary facilities enables military forces to adapt their command structures instantaneously to changing tactical situations without depending on biological personnel who require life support, rest periods, and protection from radiation hazards inherent in deep space operations. Conflicts between different branches of evolved humanity create scenarios where former allies become adversaries through genetic engineering, cybernetic enhancement, or consciousness uploading technologies that fundamentally alter the nature of human identity and motivation. Genetically modified populations adapted for life in low-gravity environments may develop cultural values and strategic priorities that conflict directly with Earth-based human civilizations, while uploaded consciousness entities operating at digital processing speeds could perceive biological humans as obstacles to efficient resource utilization. These evolutionary divergences create permanent incompatibilities that cannot be resolved through traditional diplomacy, because the participating sides no longer share fundamental assumptions about existence, consciousness, or acceptable strategic objectives. Galaxy-spanning civilizations operating at Type III energy levels on the Kardashev scale possess military capabilities that treat entire star systems as expendable resources in conflicts involving hundreds of billions of stellar systems across galactic distances, measuring 100,000 light-years in diameter. These civilizations can simultaneously conduct military operations across thousands of different stellar regions, while coordinating their strategic objectives through communication networks that span galactic superclusters. Individual battles between Type III civilizations involve energy releases that affect stellar formation processes across entire galactic arms, creating military campaigns that reshape the fundamental structure of galaxies through controlled manipulation of dark matter distributions and cosmic expansion rates. The laws of physics themselves become weapons at cosmic scales through technologies that manipulate fundamental constants, alter the rate of cosmic expansion, or trigger false vacuum decay events that eliminate entire regions of spacetime. Military forces operating at galactic scales can deploy weapons that modify the strength of electromagnetic forces within enemy territories, making chemical bonds unstable and eliminating the possibility of complex matter formation across volumes containing billions of star systems. Gravitational manipulation technologies enable civilizations to redirect the orbits of entire star clusters, creating kinetic weapons that involve stellar collisions producing gamma-ray bursts directed toward enemy galactic territories with precision timing calculated across millions of years. Warfare conducted on galactic scales transforms conflict into processes that operate according to principles resembling natural evolution rather than traditional military strategy, with civilizations adapting and responding to threats through mechanisms that span millions of years and involve the coordinated activities of quintillions of individual entities distributed across galactic distances. Military technology operating at these scales creates weapon systems that utilize the fundamental structure of reality itself, converting matter and energy distributions across cosmic distances into directed force applications that can eliminate civilizations spanning entire galactic superclusters through carefully orchestrated manipulations of universal physical constants. But these cosmic-scale conflicts remain centuries in the future, while the foundations of space warfare are being established right now through decisions made in government offices and corporate boardrooms across the planet. Today's political leaders hold the power to determine whether humanity's expansion into space follows the path of exploration and cooperation or descends into the first extraterrestrial arms race in history. Space warfare isn't coming in some distant future. It's happening right now above your head. The 2007 Chinese ASAT test changed everything, proving that satellites can be destroyed in orbit and sparking an arms race that continues accelerating today. Nations race to deploy quantum satellites, weaponize space debris, and establish lunar military bases while international treaties crumble into irrelevance. Your GPS, internet, banking systems, and weather forecasts all depend on satellites that have become active military targets in an orbital conflict beyond human control. Can humanity learn to cooperate in space before we destroy our technological civilization forever?